All right, welcome back for another episode of Connie 352. Today we are going to be going over fire protection, and we're just going to do. I think I'm just going to try to do this as one long fire protection lecture and try to cover everything that there is to do with fire protection all at once. So the first thing I want you to do is if we take a look at the Canvas website, you'll notice that I put a new section on there under the modules. If you go under modules, if you go all the way down to, there's a new section called fire protection. There's a fire protection handout. That's some copies that I made from the book that we're not using in this class, but that I'm using for my handouts. But there's also a couple of pages on fire protection videos and even a PowerPoint. So what I want you to do is to, if you need to, pause this and get ready because it'll be really handy. I think this will be the best if you look at these fire protection videos while I'm going over them so that you could pull those up. So I mean, I'm going to show them on the screen here, but I also gave them to you to look at. I'm not going to go over every second of every one of these, but this is some pretty important stuff. And normally in class, I have samples of sprinkler heads that I hand out, and obviously we can't do that. So what I've done is I've gone through and I've found a bunch of videos that I think do a pretty good job of illustrating the different fire protection systems and put it into kind of a video format so that you can follow along. So a couple of them I'm going to have you follow. They're pretty good. They're a little bit lengthy, and I don't want to go over the whole thing here on go over it since that video does. But some of them that we're going to go through kind of step by step. So first off, let's go to the fire protection handout. The handout that's just some pages out of the textbook. The whole purpose of this chapter is to, or rather the chapter that I copied, is mostly for the definitions. Fire protection systems in buildings, they're not a new idea, but they've definitely come a long way, especially in about the last 30 or 40 years. The original fire sprinkler heads, I think, were developed almost 100, 120 years ago. So it's not a new idea. However, they've been used more and more. And as codes have evolved, what you will find is that buildings that are fully sprinkled with an automatic fire protection system have a lot more freedom in design. It gives the architects a lot more choices into what they do and how they divide the building up and what they make the building out of. It changes their occupancy and their egress distances and everything. So you're going to see fire protection systems, automatic ones, in most commercial buildings. As a mechanical engineer, yes, I know I'm biased, but I am biased strongly towards automatic fire sprinkler systems. And here's why. Typically, people don't die in automatic fire sprinkler buildings. They don't. The first time in the United States that someone died from a fire in a fully sprinkled building was 9/11. And that was a bit of an unusual occurrence, let's be honest. So other than that, fire sprinkler systems have an incredible track record for safety. So much so, this is personal opinion. If you're living in an apartment or you're living in a apartment, dorm, fraternity, sorority, whatever it is, and it's not fire sprinkled, I would suggest you maybe check out moving. That's how strongly I feel about these particular systems. So let's get into the definitions and let's talk about how it affects construction in general, because it drastically affects construction. Fire suppression systems don't add a whole lot of cost to a building. in all seriousness, you can get kind of the bare bones automatic sprinkler system with sprinkler heads and probably get that done in a building for around $3 a square foot, maybe even a little less. Now, think about that for a second. You can't buy carpet for $3 a square foot. Okay? So in comparison to a lot of the finishes in a building, automatic fire sprinkler systems are pretty cheap. However, not every building has them, and there are some reasons, okay? It is true that a lot of owners are worried about the accidental discharge of an automatic sprinkler system, just breaking the sprinkler heads. That's a legitimate concern, and it's not a small expense if it happens. If a sprinkler head breaks, it's going to flow water until the fire department shows up and shuts the water off. Typical flow rate of a commercial sprinkler head is somewhere between 15 and 20 gallons a minute. Even if the fire department gets there and shuts it off in 30 minutes, you're looking at a 600-gallon mess of water. That can do quite a bit of damage to a building in the time that it would take for a fire department to show up. So, accidental discharge of fire sprinkler systems is a legitimate concern. I get it. However, there's a whole bunch of reasons to install it. All right. Now, here's what I want you to do. Outside of my lecture, one, I want you to read the handouts. I just condensed the whole chapter. This is not the whole chapter, so I want you to read everything that's in this handout. Pay special attention to the definitions and some of the codes, because not just for this class, but in your career, you are going to need to know this. You need to know here, just looking at page 266 there at the bottom left side of the page, things like what constitutes a high-rise building. The taller a building goes vertically, the more and more expensive it is going to become for the mechanical systems. Just know that. Once you get to a high-rise, and a high-rise is basically, it's around 75 feet, but it's really defined by the local fire department and how high their ladders can reach. Once you get above that height and we're into high-rise construction, now we need some specialized systems like automatic pressure control and smoke evacuation and stairwell pressurization systems that I'm not going to talk about a whole lot. Probably towards the end, I might hint at some of these systems just really briefly. But those will make a building a lot more expensive. So know that definition. All right. Also, know things like what code is going to govern. If you look at the bottom right of the page here, page 266, you're going to see some NFPA standards. NFPA is the National Fire Protection Association. They write the standards, and if you're in Jenny's class, you're very familiar with NFPA standards because they also write the National Electric Code, NFPA 70. But they also write other codes like NFPA 101, the Life Safety Code, which is an incredibly important code. Tells us things like occupancy and egress distance and travel distance and that type of thing. Conforming with NFPA 101 is one of the more difficult things that a designer is going to have to do. But other ones that are very important, NFPA 13, the standards for the installation of sprinkler systems. That is what all your fire sprinkler contractors and your mechanical designers are going to have to follow, and that is an incredibly important one as well. There's some other NFPA standards in there, but I think the most important one is NFPA 101, NFPA 70, which is the NEC, and then NFPA 13, which is the installation of fire sprinkler systems. Know some of the terms here on page 267. Read through all of them, but knowing some of them are very important. Like, what's the difference between a fire separation boundary or a fire separation assembly, fire protection rating, fire separation distance? What is a fire wall, a fire door, fire partition, and a fire area? Those are all things you're going to come across again and again and again in your career. So look through those. Those are incredibly important. Right? Now let's go over to the right side of the page where we get into classification of fires. See the 4 classifications: Class A, B, C, and D. All right, that just tells you what it classifies the fire by what's under, which is being currently combusted. In other words, a Class A fire is normal burnable materials like wood, paper, cloth. All right, those are, like most of your basic fires are Class A. Class B gets a little bit more complicated in terms of how do I fight that fire. Class B fire is like liquids, oils, grease, tars, flammable gases, and paints. Those become a little bit more complicated to put out because some of them are going to be spread by water, especially if we were talking about oils and flammable gasolines and fuels. Class C fires, a little bit more complicated yet because that goes into energized electrical gear. So things that you would use to put out a Class C fire, like a CO2 fire extinguisher, can't conduct electricity. You don't want to have to fight a Class C fire using water for obvious reasons. And then Class D fires are rare, but they are some of the worst because these are combustible metals like magnesium oxide, lithium oxide, potassium oxide, things. And the reason these Class D fires are the metals are the worst is that a lot of these metals bring their own oxygen to the fire. Like when I was on board ship in the United States Navy, the oxygen generators used a magnesium oxide metal. Now, you may be familiar with magnesium oxide if you had to take the chemistry lab and you had to do any experiments where you set it on fire. Magnesium oxide is the only way to extinguish that fire is just to cool it down below the combustion temperature. On board ship, the only way to fight that fire was really to jettison it overboard or put it in enough water that it cooled it down. You can't extinguish a fire with a combustible metal that has its own oxygen by smothering it. And that's what makes it particularly dangerous to extinguish. All right, so there's the classification of fires, which is different from the classification of hazards. There are 3 main classifications of hazards according to NFPA: low hazards, ordinary hazards, and high hazards. That has to do with what is under, or what is the worst case possible fire. Most of our buildings are going to be light hazards. For your final project, most of you will probably just have a light or a low hazard type of building. Now, I want you to analyze it and make sure, but most of you, it's probably going to be low hazard. All right, so there's the hazard level, and then there's also an important thing that we have to take into consideration when we're designing a building, and that is the use or occupancy. So first is what could be on fire. Next is what is it being used for? In other words, how many people are there? The most important classification here is going to be our Group A assembly occupancies. Think like Hilton Coliseum or a lot of the auditoriums on campus. Assembly occupancies are trickier because now we have a whole bunch of people in a very, very small area. And that's going to make firefighting much, much more important. All right. Now, then it gets into fire safety design and fire suppression systems. And first, I want to explain to you automatic fire sprinkler systems versus the ones that aren't automatic. All right, here. And now this is where I want to go over to that handout and we have some fire protection videos. We have automatic fire suppression systems, which are the ones with sprinkler heads that operate without any human interaction. And those are the ones I prefer. And then there's the manual ones, which are still acceptable. In other words, we can still design a building with a standpipe system, which is a manual system. In fact, this is the system that Town Engineering has, is a standpipe system. Let me switch over to, if you have, obviously if you're at your computer, just take a second and I want you to Google, right? Just go ahead and Google, and that's what I've done, is brought up some pictures of a standpipe system. All right, this is a standpipe system in a building. This is a diagram. Most of the time, you will find this, it's called a standpipe. All it's doing is just a vertical riser of pipe in the building that the fire department's going to connect to, and it goes to, in the stairwell, hose connections like this one. If you, in Town Engineering, if you go to the south stairwell, you'll notice this big pipe in the corner, and then occasionally there's these brass valves with these thread protectors on them. A standpipe system is not automatic. In other words, the fire department has to show up, carry in a bunch of hoses, connect to the standpipe, and fight the fire that way. For obvious reasons, these standpipe systems have a lot slower response time than automatic systems. However, they are still code compliant. There are ways to do this that still conform with the building code. I think these are a little bit antiquated, and most commercial buildings should have an automatic system, but I want you to know about this manual system. The way this works is, on the outside of a building, you're going to see a standpipe, all right, a connection. This fire department connection could take a lot of forms. There's a lot of different types of standpipe systems. They could be on an automatic system, or they could be on this standpipe system. Most of the time, we'll have a connection, a fire department connection for both. The way this works is, when there is a fire department rolls up to the building that's on fire. If it is a standpipe system, they're going to carry their hoses inside. While that's happening, the pumper truck is going to connect from a fire hydrant to this standpipe system. And they're going to use their pumper truck to boost the pressure within the automatic sprinkler system or the standpipe system, whichever it is. In other words, and here, this is one type. Let's take a look at, you might see a connection like this on the outside of a building. You might see something like this, like a brass plate on the outside with several fire department connections there. You might see a pipe sticking out of the ground like this, fairly close by, where it says FDC, fire department connection. Here's one that is just sticking out of the ground. Would probably be fairly close to a building. But the way this works is the fire department rolls up, connects to this hose connection, connects to a fire hydrant. They will use the pumper truck to boost the pressure of the existing system. If that's a standpipe, fine. The fire, once the hoses are connected, we've got city pressure, but the pumper truck is going to increase the pressure of that water as well. So then when they run in, they're going to have even more water pressure than they normally would have. If this was an automatic sprinkler system, it would just boost the pressure of the water going to the sprinkler heads. And once again, we would get more water. Either way, the fire department connection connects the pumper truck to the existing system to increase the water pressure. Now, in older buildings, you might have seen a standpipe and existing hoses. You're probably not going to see too many of these anymore. Most fire departments have had buildings remove these for a couple of reasons. One, these hoses require maintenance and inspection, and most of the time, as they age, right here where they're folded, they will get holes there. So they're they are worthless. In fact, they're worse than not having anything because now they're in the way. Or somebody tries to grab it and fight the fire, and they find that they've got a hose that has a bunch of leaks in it. Fire departments do not want untrained people fighting the fires. So they've removed these, and most of the time they've decided, you know what, we're just going to bring our own hoses to the fire and fight it that way. If you're in a building that has these, don't fight the fire, just get out. Leave it to the professionals that have fireproof gear and their own oxygen breathing apparatus with them. They've got the face masks, the shields, the gloves, the coats, the whole range of fire rated gear. Leave it to them to fight. Just evacuate and get out of their way. And because of those two things, between the leaky hoses and that they don't want untrained people fighting the fires, most of the time these standpipe systems have had their permanently attached hoses removed, and the fire department will bring their own hose into there. Now, you can imagine, by the time the fire department shows up, gets connected, hauls their hose to the appropriate floor, and finds the fire and then starts to fight it, quite a bit of time can pass. So while standpipe systems are code compliant, there are better alternatives, and those alternatives are the automatic sprinkler systems. Hold on a second. So pull up this Word file that has a whole bunch of YouTube videos, and just kind of follow along with me. I'm going to have it on the screen here, but I'd like you to follow along. These side-by-side burn videos, they're kind of informative. And I want you to pull the first one of these up and just kind of watch it as I go through it. Now, what they do is they set up two simulations of rooms. They set both of these on fire. They have, carpet, furniture, some tables and desks and stuff. One of them, the one on the left here, has an automatic sprinkler system in it, residential grade, but automatic nonetheless, and the one on the right does not. And what happens is, if for a few minutes, and I'll let you watch the whole video yourself, but what happens is here in, it's only a minute or two, that automatic sprinkler system is going to discharge and kind of suppress the fire. Right? And it ends up being a fairly boring fire on the left. The important one that I want you to watch is the one on the right. All right. So on the one on the left, smoke develops, temperature increases, fire gets going good, and then the fire sprinkler system kicks in. The sprinkler head breaks, and I'll explain here in a little bit with a video what it means when I say a sprinkler head breaks, but the sprinkler head breaks and activates, squirts water on it to suppress it, and then it pretty much goes out. In here, we'll fast forward a little bit to the point where that happens. But it's only a couple minutes into it where the one on the left, I went past it. The one on the left, the sprinkler head breaks, squirts a bunch of water on it. Yes, now it's true, everything gets soaked. And it's also true that it didn't eliminate fire and smoke. There's still a lot of damage in living room number one. But it's going to be considerably less compared to what happens in living room number two. So in living room number one, about 2 minutes pass, the sprinkler head actuates, suppresses the fire, gets everything wet, and yes, it'll still smell. Now, look at living room number three, and I'm going to fast forward ahead a little bit. There's a couple of things I want you to notice on living room number three. One is the dense black smoke that develops from this fire. When we're burning, things like couches and tables and carpets, it produces, these synthetic materials produce a lot of thick, oily black smoke. And it's that thick, oily black smoke that becomes so hazardous to the occupants. Most people do not actually die from the flames of a fire, but they are going to die from, here, hold on a second, I'm going to pause that. They die from the smoke that's produced. and the heat. Here, notice we're almost there. This video is going to go a little bit further, but here in about like 10, oh, it just happened. I'm going to go back just a couple of seconds. Take your video to about 3 minutes and 37 seconds. What I want you to look at is this table and chair. What's going to happen is at a certain temperature, the room reaches what they call flashover point. Flashover point is the point at which everything else combustible in that room, whether or not flames are actually touching it, but everything else combustible gets set on fire. Flashover is going to happen. It depends on the materials. You know, it could happen 300, 400, 500 degrees or so. I'm not sure exactly when it happens on this particular room, but even things that aren't actually in contact with flames will combust. And it's at that point that humans have very little chance of lasting. Between everything else getting up in fire, and notice this thick black smoke is really going to drop here. Between the thick oily smoke and the increased elevation in temperature, you're not going to last much longer after this point. So here, and realize this has one end of this. They've plasticed off the front of it to kind of contain the smoke and the heat. But this room isn't a normal room where it'd be enclosed on all sides and that heat would stay in there. So just keep in mind that this is only 3 minutes and about 30 seconds into it after the fire is set. You don't have much time to get out. You really don't have much time to get out once one's set. So let's just keep watching. Now watch that table and chair right about there here in just a second. There, flashover just happened. These things that weren't in contact with flames go ahead and get caught on fire. Now they're going to go ahead and extinguish the fire and put it out. Now notice, however much damage happened in living room number 1, there's a whole lot less damage than what would have happened in living room number 2. Also, the chance of somebody being able to get out of living room number 1 is much, much better. There's living room number 1. It's bad, but nothing like living room number 2. All right, go ahead and pause on this one and exit out of that particular video, right? And go back to the Word file on fire protection videos. There's this video here. I'm going to let you watch it. It shows much of the same thing, but it's still a good listen. Go ahead and watch that one as well. I'm not going to go through it, but it shows about the same thing. 2 side-by-side burns. The one with the automatic sprinkler system gets put out fairly quickly. The one without reaches flashover temperature in just a few minutes. So go ahead and watch that one. Now, I want to go down to some of these automatic fire sprinkler system videos. Okay, these are good to listen to as well. And they go through the 4 basic types of systems. All right. The 4 basic types of systems, which are your wet system, right? Wet system, dry system, pre-action, and deluge systems. All right. I will let you listen to him. But here, what I want to do is describe them, the basics to you. And if you turn to, hold on a second. If you go to that handout and you scroll down, there's a couple of illustrations on the wet pipe and dry pipe on page 283 of the handout. The wet pipe is the cheapest and simplest. Water is always in the pipe. Right? The downside of it is that if there is freezing, then the pipes could break. Wet pipe systems are meant for buildings that never come under freezing, and they just have normal, ordinary stuff. In other words, we're most concerned about protecting people's lives, not necessarily all that concerned about protecting property. We have other systems that are better for protecting property, but a lot of times in an office type of scenario, whatever the fire doesn't get, the water will probably destroy. So a wet pipe system is meant to protect people's lives. A dry pipe has the same purpose. It's just that we're worried about these pipes freezing. You'll notice in picture B, there is an extra room here around the water service entrance. And at this water service entrance, there's what they call a dry pipe valve. I have some illustrations here of it. Let's just take a look at. All right. I also include a slightly better picture of these. I'm going to put these on Canvas as well. So this one is the dry pipe, and I like this one a little better. It shows the colors, where the water is in blue and then where the air is in yellow. The way this works is, let's say that there was a fire in here somewhere and it was hot enough to cause one of the sprinkler heads to break. It's going to drain out the air pressure that's in these pipes. Air pressure keeps this dry pipe valve shut. If you watch those explanation videos, those two videos on different systems, it'll talk to you about this pressure valve, where air pressure keeps that shut. That way, if for some reason it does freeze in there, it won't bust the system. But if there's a fire, it will go ahead and actuate the sprinkler heads, and then we only get water in a dry pipe system. We only get water in that system once the air pressure goes away and the sprinkler head, because the sprinkler head is broken. All right. Here's a little bit of a close-up of the main entrance. So water comes in from the street here. We have a check valve. We have a control valve here. Now notice, see this big first valve? That'll usually have some type of an alarm on it. Might even be chained open, and it might say something like fire department valve or control valve or authorized personnel only. Usually this will be in a locked room, so you couldn't touch them anyway. If in warmer climates, like down in Florida where it never freezes, this might be outside, but in a caged enclosure or locked in the open position, right? Then you'll have a check valve, just like with the domestic water entrance, where we have a check valve that stops water from going back into the main system. We'll have a check valve on this system as well. And then notice this is the fire department connection. This is where the fire department will show up, connect their hose, and pressurize that system even higher. In other words, it just gets even more water onto the scene. And then this is a drain valve, so that after the fire is out, they can drain the system down, replace any of the broken sprinkler heads, and then go ahead and fill the system back up again. All right, now if we look at the wet pipe diagram, right, this one has water throughout the entire system. And remember, there is wet and dry pipe systems, and then we are going to talk about wet and dry agents in a little bit. So the basic systems that use water can have a wet pipe always filled with water, or a dry pipe only filled with water after the air pressure has gone away. All right, now let's take a little closer look at these individual sprinkler heads. Okay, go back to the document here. I've got a couple of animations. and videos that I want you to take a look at. So first, open up the sprinkler head animation video. Okay, this is a sprinkler head. All right, the sprinkler head itself will have threaded connections for putting into a T that's in the fire sprinkler system. The only part that you're going to see below the ceiling will be this part down here, the visible part. So that screws into place, right? And it is in a wet pipe system. It is filled with water. Hold on, let's go back just a second. This colored piece of glass has a fluid in it with a pretty high rate thermal expansion coefficient. There's going to be a little bitty glass bubble in here. And notice, different temperature of sprinkler heads are designed to break at different temperatures. Different colors, rather, are going to break at different temperatures. Once it reaches the appropriate temperature, in other words, that's what tells the system that we have a fire. We have achieved a temperature that shouldn't be in that space. That colored fluid breaks. The stopper that it was holding back gets pushed out of the way, and then water flows through the system and suppresses the fire. Most fires are most of the time, we're only going to get a couple of these breaking to suppress the fire. All right, going back to our handout. Don't forget, watch both of these videos that go through the different systems. Wet, dry, pre-action, and deluge. Pre-action system is one, think of the pre-action system as one where it's like, it would be really bad if water squirted in this particular area. In other words, there may be something that we don't want just an accidental sprinkler head break to get wet. So a pre-action system requires both the sprinkler head breaking and some type of an electronic fire detection. In other words, one of the fire alarms has to go off, or there has to be a manual triggering of the system. Right? That's just an extra step to prevent an accidental discharge of water into whatever area that it is. And then deluge system. A deluge system is very rare. It's for where we have a very, very high hazard level. In other words, if there was a fire, it would be a catastrophe. So deluge systems, the sprinkler heads don't have those stoppers in them. If they go off, the whole thing is going to go off. They're going to have water flow through all heads. So watch those two videos as it gives you videos on each of those systems. Now, let's go down to the sprinkler head, the slow motion one. Let's take a look at that one. So that's going to take you to a YouTube video, which also shows a sprinkler head breaking, but a real one. It shows it to you in normal speed. There it goes. And then super slow motion. Both of them show about the same thing. And then they stop the flow rate. All right, let's look at it again. Temperature elevates. The glass piece breaks, and then water flows. The stopper gets out of the way, and then water flows, and it squirts water until the fire department shows up to stop it. Now, something important about these sprinkler heads, that little piece of glass, it's a piece of glass. So if it is hit, or if it is poked or something, like somebody throws a football or a baseball, maybe in an apartment or a dorm, it hits that, a hard enough physical shock could break it, and the sprinkler won't know any different. It'll operate just the same as if that sprinkler had broke because of a rising temperature. And that is the part that makes building owners and facility managers nervous, especially in apartments and dorms. Maybe some of you in the dorms that this has happened to, or maybe like in a locker room. Some of these sprinkler heads in a locker room hang down, and they make a really tempting place for someone to hang a coat hanger for their clothes. Don't do it. A metal coat hanger put in the middle there could easily break that sprinkler head and cause it to flow, and it'll flow. And the water that comes out of it, this is a test. So that water looks pretty clean. If you take water that's been sitting in a pipe for 10, 20 years, it's not going to smell nice and it's not going to be clear. The first water that flows through that is going to be brown or rusty or green. It's going to stink to high heaven, and you're not going to like getting squirted with it. So just as a thought, be careful around the sprinkler heads. All right, let's keep going. Go back to this page, right? And I've got several here on how does a sprinkler head work and that type of thing, you know, with the animation and with the sprinkler head discharge. Go ahead and watch those. They're very, very similar. This one's a little bit better because it actually shows the glass piece, I think, a little better, and shows that little bubble in there. So I've got the red liquid. Okay. It'll show you the bubble right here in just a second. The glass piece holds this stopper in place. It's got a little bit of an air bubble in there, and that liquid, as it expands, it'll compress the air bubble, and then once it can't compress anymore, as it expands, it'll crack that piece of glass. Piece of glass is cracked, water pressure does the rest. If this was a dry pipe system, first, the air would come out of there, and once that air pressure drops low enough, it's going to cause water to flow through the system after that. All right, back to the handout. All right, now what if we didn't want water to be the mechanism that that extinguishes the fire, and why might that be necessary? Well, for example, here, this is a foam system. In areas where we are worried about a fuel fire, gasoline, diesel fuel, oil, something like that, water is going to spread that out, and the liquids will ride along the top of that system, or of that liquid. So the fuel riding on the water will actually spread it out and make an even worse problem. Specifically, and this happens to be an aircraft hangar, and this test was actually done in Des Moines. I've only designed a couple of these systems. One of them was for a National Guard, the Waterloo National Guard, where they kept the Black Hawk helicopters, an aviation hangar for that. And I learned a few things about these foam systems. The foam systems are designed, you design it specifically for a room and for a specific aircraft. In other words, you design it so that it discharges foam high enough that it covers the fuel tanks for whatever aircraft that you have in the hangar. In other words, you designed to go up to the height of the fuel tank specifically for like a Black Hawk helicopter, if this is where Black Hawk maintenance is done. If you're doing it for, say, a 747 or a jetliner, you're going to design it to go up to the wings, because in most of the jet aircraft, the fuel is held in the wings. So you have to put in as much foam as it takes to cover it. Now, it's not going to drown anyone. I want you to think of the foam as almost like a soap suds. All right? So the way this works, either with a manual or an automatic detection, right? First, we're going to get an alarm, and you'll notice around here, there's going to be some strobe lights go off. All right? So the strobe lights go off. Give anybody that's in there a little bit of a head start to get out. Now notice around here what they've done is they've put plastic all over the walls up to about 10 feet. So once the system gets going, it mixes, it injects the soap suds, if you will, with the water, and then dumps it into the hangar bay through these large pipes and nozzle discharges. So, I mean, look at the sheer volume. It's only got a few minutes. They're timing it. They're doing a test, and they're timing it to see how fast it can fill up this hangar. And then it for the test, you don't fill the entire hangar. You do like a controlled fill, like you figure out, okay, 3 feet or 4 feet, time it and see how long it takes to fill it to that level. So it fills the entire thing up to the level necessary for whatever aircraft is in there, and then it extinguishes the fire this way. And it's a pretty amazing thing to see one of these kick off. It'll just dump suds in there like crazy. And then, it's got to do it within a certain amount of time. Now, this is a successful, and I'm going to fast forward a little bit. You can watch the whole thing slowly if you'd like. This is a successful test of a system here in Des Moines. Now, I've got another video, or rather, it's a series of pictures from what would be described as a non-successful test that was done. A friend of mine sent this to me. This was not my project. But this was done, let me think here, on an Air Force base in North Dakota, if I remember correctly. I think the actual Air Force base is on the Ellsworth Air Force Base. Here we go. It was only supposed to be a test. It was only supposed to last a few seconds, right? There is the valve system and the pump. There is the container of the fire protection foam that's going to be mixed with the water. They put a bunch of markers down, and they're going to time how much gets pumped in how long. I want to say that this particular hangar was for a B-1 bomber, but I'm not sure on that, and it's not really important what it was. So instead of only running for a few seconds, this particular one discharged the entire contents into the hangar, and they were not really counting on that. So it just kept filling and filling and filling, and you'll see this one fills it up almost to the structural steel. There's the Air Force guys watching going, oh my goodness, what a mess. There is the whole contents now in the hangar. We have a few pictures of some of the guys that were on the floor. See, it doesn't drown anyone. You just kind of have to push the bubbles out of the way. All right. And then afterwards, they open the doors and let all of that escape. Okay. And it left kind of a big mess. Now, the best picture is coming up. All right. The fire department gets there. All right. Everybody is covered in suds. Right. Guys that weren't planning on being covered with suds are just absolutely covered. Like I said, not my project. I didn't do it. All right. And then outside, they drain all these suds out, goes into the store, drains, fills everywhere, which is nice. Hey, the system works. And then the best part, though, is one of the guys' trucks. Parked his truck there, and the best part is he left his window down. All right. No, that is not Photoshop. All right. So this is I'm going to have to say it was a successful test. It just went a little further than they were planning on. All right. So the foam systems are for fuel-based systems. Fuels, oils, those types of things. All right. Let's go back to... Now, what if it's something that you don't want to damage? And there's a couple of different systems here. One of them is what's called an FM200 system. Something that you don't want to damage. In other words, I don't want to use water to put this fire out because I'm really interested in protecting whatever the material is. Like a common example of this would be a computer server room. It's not uncommon for companies, for their data, to spend millions upon tens of millions of dollars just for the computer servers. And think about it. Obviously, here lately, think about how vital the electronic information in a building or in a business is. I mean, if we look at like Principal Financial, Wells Fargo, US Bank, any of these insurance or financial institutions, the data is the business. That is the valuable part. So if there is a fire in, say, one server, we don't want the fire suppression system to destroy it. So an FM200 system, where we have a gaseous-based system, that's going to be the type of system that we are going to install to protect like a server room. So the important components, we're going to have a control panel, and we're going to have some smoke detectors. We're going to have alarms and horns and strobes. We're going to see how they all interact. We're even going to have an automatic pull switch, and we're going to have an abort or a pause switch so that we can manually stop it. All right, an FM200 is a gaseous-based system. Say this server room, notice above each bank of computer servers, we're going to have a detector and we're going to have a nozzle. They're going to be in two different zones. And this room could be as big as you could imagine. Think like Facebook or Microsoft or any of those large buildings that are there by Altoona or Des Moines. So think like there's a fire in one of these. We get a fire alarm. Fire alarm says a system to the control panel. The control panel takes that alarm and says, hey, I better let anybody that's in that room know. The bell starts to go off. The alarm horn and the alarm strobe starts to go off within the space itself, right? That smoke spreads to zone 2. So now, right, we're a pre-discharge alarm. It says, hey, we're about ready to discharge the chemicals. No, the chemicals aren't deadly. Still, you should get out. Gives a chance for everybody to get out. Now it starts a countdown to the discharge. Now, the countdown can be aborted. If there's somebody in there and they're like, wait a minute, that's a malfunction. Wait a minute, there's some reason I can't get out, or I don't want that to go off, you can abort the system. Now, just keep in mind, for a room of about this size, you may spend $100,000 on the extinguishing agent and the system. So you really don't want that system to discharge unless there really is a fire. That's why there's an abort button. So it discharges, it extinguishes the fire, and most importantly, prevents damage of the rest of the items within that server farm. Now, you could also manually discharge this as well. Right, there's going to be a manual discharge, looks like a fire alarm, but a manual discharge release on the outside of the room as well. Agent discharges, and then same thing happens. Now, something important here to note, when it's discharging, all right, let's go back a little bit. You'll see a view of not just above, but also below. These servers are on raised, and I'm there. Notice this flooring system. Most of the time we're going to have a computer system like this on a raised flooring system. This is going to be full of all of the telecom wires going to these servers. This will also be where they pump in cool air from the air conditioning system. So there's also going to be discharge nozzles below here as well. Something else that this control panel will do is it will shut off the air conditioning system and stop air from recirculating through here, because we don't want to fan the flames and we don't want to spread the smoke that fire is going to cause either. And like I said, probably for a room of this size, you could easily spend a couple $100,000 on the extinguishing systems, but keep in mind, with that many server racks, you could spend tens of millions of dollars on the servers and an untold amount of value on the information that those servers hold. So the fire suppression system, while expensive, is a fraction of the value of the intellectual property and computers that are within that room. Now, FM200 is commonly used as a common extinguishing agent for computers and servers. There's also another agent that's not used just for computers, but is also used for priceless antiques. Okay, here's a clip from Good Morning America. They did this years ago, and I had a similar demonstration where some of the salesmen came to our office, and just like on this video, they had a little tank of this. It's called Sapphire Clean Agent System. The Sapphire system is interesting, and there are others. Sapphire is the trade name. There are other agents that are competitors to it, and they're much the same. Anyway, they're a clean agent. They're not just clean, and by clean, I mean they don't hurt the materials that they touch. Same way with, and the interesting thing about this one is, it doesn't damage paper, not just electronics, but also things like paper or computers or anything. Here, I'll show you. So here's a fire. They go through and they show the system discharging from the roof. It discharges, cools the fire down, breaks the bonds of the fire, and extinguishes it. Now, on this video, you'll see, and this is an interesting video. I would encourage you to watch it with their voices, watch the whole thing through. But there's some things that I want to point out here. So they've got a tank of this stuff sitting there. It looks just like water. It behaves like water. It moves around like water. You would think it was water. But when it comes in contact with things, it has some very, very peculiar properties. And what they'll do is, the guy demonstrating this particular tank of material, what he's going to do, see, they touch it, it feels like water, except it dries from your fingers almost instantly. When you pull your hand out of it, you can't feel it anymore. And what this guy does is he dunks a piece of paper in there and pulls it out, and it dries almost instantly. Okay, so he's got a phone book, a book he sticks in there. He pulls it out. It's like nothing happened to it. The ink doesn't run, the paint doesn't smear, nothing. And that's what makes this really good for not just electronics, obviously. He puts this, and this is what the salesman did at our office. He actually took his laptop computer, turned it on, and used it while it was in the tank. Just sat down there and typed some things on his screen. Doesn't interfere with electronics in any way. All right. And then I think, if I remember right on this video, he's going to take that computer screen while it's working and dunk it in there as well. All right. Now, what they do here is they have one of their production assistants come. She dunks her hair in there. And then, like, instantly, it's dry. You can't even feel it. Can't even feel the liquid. So I'll let you watch all of that. On one of the videos on this stuff, they also took a watercolor painting that his kids had done and dunked it in there and pulled it right out, and it also did not smear any of the watercolors. So a system like Sapphire, that would be a dry agent, a clean agent, dry agent system. And there's several videos from these guys that you can Google and take a look at on YouTube. But those don't damage anything. And let's say that you had not just computers, but maybe you had a museum, or you had some art that you wanted to protect. This would be the item of choice to use, because you wanted that to live through whatever fire extinguishing event, and you didn't want that rare art to be damaged. All right. So now let's go to a different type of fire, and let's talk about kitchen fires, grease fires. Grease fires are similar to other fuel fires in that water is going to spread the fire rapidly and catastrophically if it's used. The difference between, like a hanger that we use with foam is that the grease fire, that grease is already at, if it's in a fryer or a cooker, it's already at an extremely elevated temperature. And so we want to make sure is to not, like if we were to put foam on it, that would still cause the water in the foam to expand and cause a problem. And I'll show you a slow motion video of why water on a grease fire is catastrophic. But this is an Ansell system, a different type of Ansell system. I believe this is the Ansell Piranha system. In a commercial kitchen, you're going to see one of these here. Let's go back. You're going to see one of these stainless steel boxes on the wall. It's going to have a propellant and it's going to have an extinguishing agent. When a fire is detected, it's going to spray the propellant over all of the cooking surfaces. You're going to have these little nozzles. This isn't like a water-based system that has, one nozzle breaks. If there is a fire detected, it's going to dump the entire contents of this into the grease area to extinguish that fire, and then it's going to follow it up. Now it does follow it up with water to cool the components down, but at first it's going to dump the propellant. So here, within the hood itself, if you go back to about 30 seconds into this video, there is this little spring-loaded plate that has solder in it. Once it heats up to a certain temperature, that plate is going to break. Once that breaks, it is going to discharge the propellant into the fire extinguishing agent. That is going to cause the fire extinguishing agent to go through the pipes and go to all of the nozzles and spray all of the grease producing facilities. It's going to dump the entire contents in there, and it's going to make this foaming, it'll end up being like a brownish foam that ends up coating everything. Now, this video makes this look nice and neat and clean, right? And if we go ahead a little bit, you'll see, here's a deep fryer and it's got this nice white foam. It does not actually look like that in reality. And so I've got a different system here. I've got a different video that shows an actual test discharge on an actual grease fire. All right, so this is a Tyco Ansell R102, right? We have an actual fire, this is a test fire, okay? And they compare this method with a couple of other methods towards the end. I'll let you watch all of that. But so here we have a staged grease fire, and I'm going to let it, all right, fast forward ahead till you get the grease fire going pretty good. I think it takes about 2 minutes into the video. The grease fire is going nice and hot. The grease system, or the Ansell system, is going to discharge. It's going to dump the contents onto all of the cooking surfaces. Right. There we go. There it goes. It dumps the contents on there. And what you'll notice here is that the deep fryer, as it mixes with that grease, it'll start to foam and overflow, and you'll get it like frothing out of there, this brown, gross, disgusting mess. And then here towards the end, They'll give you a close-up. There we go. They'll give you a close-up of what that particular deep fat fryer looks like after this is discharged. It's not a pretty sight. Once this extinguishing agent discharges, it's going to make quite a mess. And you're probably going to have to replace and professionally clean all of the different kitchen items. Now, this video goes on to compare this versus a fire blanket and this versus an extinguishing agent, others types. Look, this video was produced by people selling these systems, so of course it makes their system look the best. But it's very true. These agents are really the only way to handle grease fires, and pretty much in any commercial kitchen, you're going to see these Ansel systems or competitors of Ansel used. All right, so here's a video that really shows what happens and illustrates why water on a grease fire is such a catastrophe in the making. This is an old video from a show called Time Warp, where they'd have a super high-speed camera, and they would videotape things to be able to see. The slow motion really revealed some details that you might not see. So they go through and actually dump on purpose water on a grease fire. Now, what's really illustrative here is what you can't see, and what the slow motion reveals is why you get this huge raging ball of fire coming out of that incident. So, you know, they dump the water on there, and we have this raging fire. It's not just that the grease is following along the surface of the water. I mean, it's not the surface of the water doing that. What's happening is when they dump the water into the already hot grease, when they dump the water into the hot grease, that grease turns the water into steam, and those steam bubbles push the grease out and around to find the flame. All right, so let's see that. He just demonstrated the right way to stop the grease fire, but so here, slow motion, water goes into the pot. Notice at first you see steam, and you see these little chutes. That steam is acting like a propellant for the fuel. Not only is it propelling it, but here, pause right here at a minute 56. You'll see these little streaks. What's happening is that steam is taking that grease and oil, and it's atomizing it. It's creating all these little bubbles. It's doing something similar to what happens in a carburetor or a fuel injector. It's increasing the surface area. Instead of all that grease being in a pan, it's increasing the surface area of that grease by making it into little propellants that it's spraying everywhere. And also here in one of these videos, you'll see that it literally pushes every bit. Notice this big explosion as it hits the burner and ignites. And notice all these little streamers. It's got a bunch of surface area, and so it almost explodes and burns all that fuel almost instantly, creating an incredibly catastrophic event. Right? And they do the same thing. They do this. The video here only lasts about 5 minutes. I'm going to fast forward through some of it. But they do the same thing again and again and again, where they dump water on it. But the one I want to show you is this clear pan, because you can really see the effect of the steam well when they do that in slow motion. All right, right at 2 minutes and 56 seconds. So the water goes in. Notice how it's already, the instant it hits this hot oil, it already flashes to steam. You see these bubbles. They actually go through and pull every last bit of this oil out of that clear pan. And that's what you see going on here. That grease is so hot that it instantly vaporizes that water, uses that steam to propel that grease everywhere, and then you get the resulting fireball after the effect. It's really cool to see it in the slow motion, and that's why water is the very last extinguishing agent that you want to use on this. All right, I'll let you watch those several times. It's kind of a cool video, but the point I think is made is that water and grease represent an absolutely catastrophic fire. All right, we are back with another discussion of fire protection in Connie 352. All right, now this time we're going to be discussing one of the more significant events in fire protection history in the last 20 years. It is the Station nightclub fire from Warwick, Rhode Island. All right, so to do this discussion, do me a favor, pull up the Station nightclub fire protection videos, pull up that handout. And what we're going to do is we're going to study the Station nightclub fire. Now, this affected the fire protection laws all across the country. And I mean, it even changed the way occupancy was enforced even here in Ames. For example, when I was a student at Iowa State from 1992 to 1997, the bars in Campus Town weren't too crowded until you couldn't get the door shut. I mean, it was just so crowded in there that you could barely move around. After the Station nightclub fire marshals everywhere cracked down on occupancy, and I think after you watch the videos here, you're going to see why that's the case. These videos illustrate why we need to take codes and code safety seriously. Things like occupancies, things like egress, things like how exits are marked and how many people can be in a building, and whether or not we need fire sprinkler systems. Okay. So what I want to do is I want to give you a little background about the fire itself, what happened, kind of like some reference points, and then we're going to watch a video of the fire because there was a reporting team in there that night that was actually videotaping, and we get some video from inside and from outside. Little word of warning on this. I want you to watch this. I included a link to the YouTube video of this. When you listen to it with the volume up and you can hear the screams of people, it is disturbing. Okay, make no mistake. This is not a fun lecture. This is not a fun video to watch. However, it is very informative and instructive, and I really want you to watch it. Watch the whole thing. We're gonna go over it here, but I want you to watch it on your own video screen on your computer because you'll be able to see things a lot better that way. So watch it. All right. So a little bit of history. The Station nightclub was not a very big place. All right. 70, 80 feet long. All right. 70 feet deep. Not a very big place at all. Could only hold, couple hundred. For that particular day, they were having a band, an 80s hair band, Great White. They had a platform and a dance floor, and they had removed out of the club seating here, they had removed all the tables and the chairs so they could get more people in there. The night of the fire, they were way over their occupancy. I want to say they were somewhere between 400 and 500 people in this building, which was more occupancy than they should have had. Most of the people that were there that night were in the club, sunroom, and dance floor area. Basically just one big room with a band at the far end. A couple of important things to note before we start the video. One, notice this exit over here. Right there. Okay, notice that exit by the band. Most people that were in there did not know that exit was there. There's even a report that maybe as the fire started, people went for that exit, and one of the bouncers said, "Nope, this is only for the band." I don't know if that's true or not, but just know that there weren't a lot of exits, and they weren't very well marked. All right. Also, notice the main entrance and the main exit. Something important here. See how you come into here and then you have to turn, and then you go through a single door right there on that towards that double front entrance. But there's a single door there. Something important to note about that. It's made that way because that does a really good job of controlling access. If you're charging admission like they were that night, this makes it easy to control access and make sure everybody's paid. It creates a mess when it comes to exiting, and we're going to see that in the video. So just remember that. Also, most of these windows along this wall were blacked out, and very few of them were actually ever busted out to let people get out through the windows. All right, so keep that in mind as we go through this video. Go to, see where it says Station Nightclub Fire Wikipedia. All right, just go to that. I'm not going to look at all of it with you, but there's some good facts in there, and you should read it after this discussion. All right. Okay, the basics of the fire. All right, Station Nightclub Fire, February 2003 in West Warwick, Rhode Island. It killed 100 people and injured 230. Only 130 escaped uninjured. Those are not great odds. So let's say that there are about 460 people there at the time of the fire. 130 got out uninjured. When the fire started, you had one chance in 4 of getting out unhurt. That's not good odds. Okay? Not good odds. What happened? The basics. And we'll see this. The band was playing. Pyrotechnics were set off by the band manager. And apparently, this particular venue had had some complaints of noise in the past. So at some point in the history of the nightclub, they had added a bunch of spray-in foam around the band and stage area to deaden the noise to the outside. Common practice. They also apparently painted that foam black. Some of this was a polyurethane foam. Some of it was a polystyrene foam. Apparently that polyethylene, right? The polyurethane foam was incredibly prone to fire. And when it burnt, it develops a dark, deadly smoke, produces carbon monoxide, obviously, and hydrogen cyanide gas. Apparently, if you only inhale this a couple times, it's going to cause a rapid loss of consciousness and death by suffocation. All right? It was the wrong stuff used in the wrong place. All right? Now, so before we take a look at that particular incident in the video, check out this other nightclub fire that happened only a few days before that in Minneapolis at the Fine Line nightclub in Minneapolis, Minnesota. If you Google this one, you will find almost no information on it. There is very, very little information on the Fine Line fire because the Fine Line fire is boring. All right. Let's see here. February, let me think here. Just a couple days prior to that, or around there, February 17th, 2003, another 80s big hair band had pyrotechnics and they lit the ceiling on fire. Same exact thing happened. However, on the Fine Line fire, nobody died because that building was fire sprinkled. Now, granted, nobody was happy. It did a couple $1 million worth of damage to the club, had tremendous amounts of smoke damage, water damage, fire damage, had to be completely gutted and repaired, but everybody made it out alive. And not just alive, everybody made it out unharmed. All right. So today, when you Google Fine Line nightclub fire, you can find almost nothing out on it. However, if you Google the Station nightclub fire, there's all sorts of information on it. So let's go to the YouTube video that I included in that handout, Station nightclub fire. All right, I'm going to play it here. You'll probably be able to see it better if you play it on your own computer. All right, but play along. You can maybe listen to me and play this video at the same time. But I want you to play it. And we're going to leave a little of the music on so you can hear a little bit. Okay? So, cameraman is there kind of in the middle of that dance floor area. Couple seconds into this, right there. 30 seconds into the video, you'll see the pyrotechnics and standard part of a stage. Look, all sorts of rock bands use pyrotechnics and fire and sometimes explosions in their performances. When I was a student here at Iowa State, Metallica played Hilton Coliseum in like 1996. They had explosions, fire, stages. They even had a roadie fall from the ceiling on fire, all part of it. All right? It's not uncommon. However, in this particular instance, the pyrotechnics, as you'll see this right there at the 32-second mark, set the ceiling urethane insulation on fire. Now, note this. This is very important. 30 seconds in, fire starts. So the reporter, you'll notice, reporter starts moving out of there. He's not there for the performance. He's just reporting. However, he's looking through the lens. He sees the fire and he starts backing out towards that entryway. Now, notice no one else is moving yet or even really paying much attention to this. There's a little bit of when something like this happens, there's a little bit of cognitive dissonance. In other words, people are thinking, is this part of the show or is this wrong? If this is wrong, isn't somebody going to do something about it? So there's a little bit of a hesitation here before anybody actually starts to do much. So let's just hit play again. So he starts out, he's backing out. There, 10 seconds into it. Look at the blaze at the front. That's only 10 seconds after it ignited. And you start to see a few people pointing towards the door and they're like, hey, let's get out. All right, so 10 seconds in. In this 10 seconds, well, now it's 15 seconds. Look at all the people the cameraman has moved past. He's passed a whole bunch of people who are still looking at the stage, and there's that one guy pointing towards the back. All right, so now music stopped. Everybody's realizing, hey, I should probably get out. People are milling around, and they're coming to that single door there. 20 seconds into it, the fire alarm goes off. Now, notice over here, you see this curtain? It actually hid that band exit. Their I think it was their bus, their tour bus was parked out that door, and this black cloth hid that exit because that was only supposed to be for the band to come in and out. So most people wouldn't even realize there was a door that way, and they're definitely not going to go closer to the fire. So almost no one went out that exit. All right, so let's hit play again. We're at 30 seconds into the fire. Right about now, the cameraman is going to make it to that single door. There. He's at the door jamb. He's just barely through the door, and now he's got to turn left and get through that other single door to get out. As he goes through this, I want you to look at some of the people that are in this passageway. Now, remember, this isn't very big. There's people standing there that probably don't even know the fire's going on yet or know what to do. They're standing there, and they're kind of in the way. And this exit creates a terrible... There's someone there. There. See this guy? He's stuck because this double doorway passageway narrows down to a single door, and now he can't get around that because of the crush of the crowd. All right, let's keep going. We're 50 seconds into the fire. Cameraman passes that single door, and then he's going to pass. Notice this. Someone else is standing in that doorway. Now, we're not even a minute into this fire, but notice the smoke that's already billowing out through this passage. That becomes a pretty critical item. Okay, so that he gets out. There, he's through the double doors, and he's out to down the stairs, and he's out to the side of the building. Okay. Notice the screams. Things are getting desperate inside. He runs around to the back. Takes a look at that stage door. Comes back to the front. Here, notice these windows have all been painted black over. Nobody busts them out to get out. Notice the smoke that's already screaming out around the window frame. If the smoke is that bad coming out of that window frame, imagine what it's like on the other side of that glass. Okay. He goes back to the front. Now look at the front. 2 minutes into it, there is a crush of people that have piled up like logs here at the double door entrance. Somebody falls, somebody pushes somebody falls, somebody tries to crawl over them, somebody tries to crawl over them. Suddenly, nobody can get out, and we have a crush of people in those double doors. Notice the black smoke coming out. If you were to stand up to head height and take a breath of that, it wouldn't go well. Over on the left, you'll notice some people start breaking out windows. Good thinking. Some people start breaking out windows and getting out that way. Some people jump in here to help out. Some good Samaritans try to help pull people out of there. There's a huge crush of people. Now, as the reporter walks around and does some videotaping, you're going to see some people that are just standing there walking. Maybe they're walking with a dazed look on their face, whatever it is. I don't want you to think of them as uncaring jerks. A lot of these people are going to be in a state of shock. Shock where the mind cannot handle and process what they're physically seeing happening. They cannot process it. Some people run. Some people freeze. Some people fight. You never know how someone is going to react to this. And some of these people don't know what to do. Some of them jump into action and start pulling people out of there. Some of them run away. But some of them are just going to stand there looking at it, not knowing exactly what to do. And so it continues. People are trying to help others out of the front. Notice the thick black smoke billowing out all of the windows and that main doorway. We are 2 minutes and 15 seconds into it. 2 minutes and 15 seconds into it. It's still possible to get out, but your odds are dropping drastically. If you were to stand up and take a deep breath of that thick black smoke, I think it'd probably render you unconscious. Okay, here we are at about 3 minutes. You see people just crushing there, just crawling over each other, trying to get out of the double doors. Other people walking around looking for others. Some don't know how to process this. Now, there's a little bit of a flaw in the video. Just wait it out. Kind of reverses and then goes forward again. Right? All right. Continue going. People still trying to get out. You start to see some people that are just in shock and don't know what to do. Maybe they're injured. Maybe they're terrified about friends. All right, let's keep going. We are at 3 minutes and 30 seconds. Did you hear the girl there at the 4 minute mark on the video? She says, "Oh my God, I'm bleeding." She didn't even know that she was bleeding. Not an uncommon reaction. Didn't even know she was injured because of the adrenaline spike. Okay. Let's keep going. All right, now, here in a few minutes, the reporter is going to run around to the side of the building. It's really hard to see. But before he does, I want you to remember how many people were stuck there at the main double door entrance when he comes back. All right, so he runs around to the side. Notice all the cars that were right there by the entrance. It makes it difficult for the fire department when they show up. This is why fire lanes exist and why strict enforcement of fire lanes is so incredibly important. So he runs around to the back. Notice at the 5 minute mark, we're almost to the 5 minute mark, and we already hear the sirens from the fire department arriving. Look, that is amazing response time. They are on the way in 4 minutes and 30 seconds after the fire started. They are already on the way, and you can hear the sirens. That is an amazing response time, and yet still 3/4 of the people that were in there were either dead or injured. Now notice on this picture, he's looking in. There's this thin little, probably only a foot and a half high area. But other than that, that thick black smoke is all the way down to the ground. Most likely, anyone that was in that first room is probably not getting out by this point. Okay, we hear the fire sirens getting closer. Reporter runs around to the side. You see the fire screaming out of, and that would probably be the storage areas, office areas, kitchen areas. Okay. He looks back in there at the stage entrance. He goes around to the front part of the building again. Notice the vehicles in the way again. There's the band's tour bus right there. So he goes around that, goes around the tour bus. There's the fire department. Fire department is parked there in 5 minutes after the fire starts. That is incredible response time. It wasn't a lack of response time that caused people to die. Notice right here over this guy's shoulder. That is the entrance where all those people were stacked up. There. Now, hold on in just a second. There's a pretty graphic part here where the last person that I know of gets out of that entrance. You're going to see somebody come out of that entrance in just a second. There. Right there at the 6 minute and at 6 minutes 17 seconds on the videotape, right above that guy's head, you're going to watch somebody on fire coming out of there. That's the main entrance. There's no one else getting out of there at that time. This is mere 6 minutes. We're not even at the 6 minute mark after that fire started. If you didn't get out in 6 minutes, this is what it looks like. You probably only had about 3 minutes realistically to get out without being injured. And that's the main entrance, the double door entrance right there. You can see the guardrail there. 6 minutes and the building is completely engulfed in flames. In a couple more minutes, you're going to start to see here, there's a hose. 6 minute marks. At the 6 minute mark, the fire department is already putting water on the fire, and yet it's too late. Reporter walks around the edge, takes a look. Here in a second, he's going to set his video camera down, and I'm going to stop. Okay. All right. I'm going to back out of this. Okay. There are a couple of other videos that I've included on here that kind of talk about the aftermath of the fire, kind of what happened with regards to the victims. Here, let me just summarize. Everybody that's involved with this gets sued. And I do mean everybody. Not just the owners of the nightclub. The owners of the nightclub actually ended up doing federal prison time. In addition to the financial lawsuit, they were also sued, or not sued, they were also charged in criminal court. The manager, I want to say, of Great White also ended up doing prison time for negligence for setting the fire with the pyrotechnics. Everybody involved was sued. The company that did that videoing, they were sued. Budweiser Beer, because they sponsored the event, they were sued. The manufacturer of the foam was sued. Let's see here, Home Depot that sold the foam, I believe, was sued. JBL Speakers was sued. And you have to understand, when something like this happens, everybody involved is getting sued. You might say, well, good Lord, what possibly could Budweiser Beer have in terms of responsibility? However, and in a case like this, where you have people that are injured, people that are aggrieved and wronged, they're going to draw as many people as possible onto what I would call the wrong side of the courtroom. And that is, you're setting beside people that have a massive amount of responsibility, like the owners of the club that allowed it to go over their occupancy, that hid exits. You know, there's just tons of violations. All right. Something interesting about this particular fire, though, keep in mind that this club was not required to have automatic sprinkler systems. It was not required at the time that it was built, and it was not required at the time this event happened. It was not required to have an automatic sprinkler system. However, they could have, and just remember, it would cost right about $3, $4 a square foot. All right. And once again, compare this to the Fine Line nightclub fire, where everybody got wet. I'm sure a lot of big 80s hair and your finest your finest acid wash denim jackets and jeans got ruined. But other than that, everybody ended up going home alive and uninjured. Here, this particular fire drastically changed NFPA 101, Life Safety Code. changed the attitude that a lot of the local fire marshals have with regards to fire inspections, occupancy inspections, and occupancy enforcement. Really changed the way everything was done. So here's what I would like you to do. I'd like you to watch the rest of these videos that I have on there. All right, they're informative. They're pretty good. Okay, watch that. If you haven't already, if you weren't following along, watch that video on YouTube because it's pretty illustrative. And remember, I show this to point out the importance of following codes and the life and death nature that codes have. All right, we're gonna pause here, and the last thing, I think I'm gonna have one more lecture on fire protection where we do fire main sizing. All right, so let's pause here, and I will see you next time.